Hi, I'm Larry Puckett, the DCC guy. In the first part to this series on signals, I showed you the circuit or the setup that I use on the Piedmont Southern to control the movement of trains across the Gantlet Bridge section over the Rockfish River between Charlottesville and Lynchburg, Virginia. Now, what I want to show you today is how that circuit actually works. So we'll take a look at the circuit board and then we'll move on and I'll take you to Rob Paisley's website. And Rob is the fellow located up in Ontario, Canada, who designed the circuit. It's not a circuit I designed. I just got it from his website and ran with it. So he's the one that originally developed this circuit, and on the website you'll see he has just tons of train related or model railroading related circuits for signals, for train detection, all kinds of things. He has a lot of stuff there. And for a lot of it, he can provide the circuit boards and even whole kits for some of these products that he designs. And as I've said before, in my book, Wiring Projects for Your Model Railroad, I used his circuit and circuit board kit for controlling the crossing gate and the signals and the bell, everything on the Piedmont Southern in Charlottesville, Virginia. And it works very reliably, very good once you get it set up and installed under the layout. So we'll take a look at his designs and specifically the design that I'm using for this circuit board. And once we have a chance to look at the design on his website, I'll come back here and I'll show you my hand-drawn version of that circuit, because it's a little bit different when you go from a schematic for an electronic circuit and something that you can actually work from as a plan for doing the wiring and layout on a PC board, for example. So let's go ahead and get started with that. Okay, so here is this is again the old circuit that I used that was in the May 2015 issue of Model Railroader, and that worked fairly well. But I always wanted something that was a little bit more reliable and not as sensitive to low light. So this is the circuit that I got from Rob Paisley's website. Now, as the name implies, this circuit is designed to control a relay. And this orange device here that I used is the relay. And these are basically an electronic switch. So you provide power to them, you turn them on, you turn them off, and they internally will flip a switch, just like flipping a switch on the wall in your house. Except that in this case, it has two positions. It's got a normally open and a normally closed position. And that just determines which one of these LEDs is going to be powered at any given time. So what happens is when I power this up, you can see it comes up green so that trains can move freely across the bridge. But if there's another one that comes along and covers up the photodetector, we get a red light. So what happens is when you put this in the dark, when you cover up the photocell, it changes its resistance to the flow of a current through it, and the comparator here, the voltage comparator chip, detects that by comparing the voltage across this photodetector. And then it in turn will turn on this transistor. And this transistor has enough power to control the relay. And so when you're setting this up, you have to be aware of this normally open, normally closed situation. And usually that information is provided in a data sheet for the particular relay that you purchased. And if you don't get it with the component, it's usually available on the website that you order from, or you just take the number and look it up on the internet and it'll be there as well. Now, when you set this up and make all your connections, you just plug in your green and your red LED wires into your normally open and normally closed contacts and turn it on. And if it doesn't work the way you want, then you just power it down, swap the two leads, red and green, and turn it back on again, and it should be fine then. So that's very straightforward, easy way to check it when you first start it up whether or not you get your green or your red, and the logic behind that. Now, one thing I do want to point out and make sure it's clear, for the operations on the Piedmont Southern, I had two of these boards, one located with a detector at each end of the detection circuit, so that a train coming in either direction would control the signals located at each end. So you have to have at least two. Now, in this case, I only used one phototransistor detector and put a 20-second delay on the release or the change back to the from the red to the green. That gives it enough time, or trains enough time, to get through that section on the layout. One thing you can do is use the multiple detector circuit that Rob shows on his website and have two or more of these phototransistors, one on each side of the bridge at each end, and that means that you would not need the delay built in like I did here. So that's just one quick tip. And I did actually try using two of these in series, but I ran into a problem with false detects as soon as I turned on the DCC system, and I think it was because of the long run of unshielded wire between these. So in the future, I've ordered some shielded wire, and I'm going to give that a try, see if that works. I can also try some other electronic changes to the board here to try to change the detection sensitivity. But for now, it works great using the delay. So if I were to go ahead and combine these components in a much more compressed situation, I could probably get this board down quite a bit. But, you know, there's only 1, 2, 3, 4, 5, 6, 7, 8, 9 components really here in this circuit. So it's very simple. This is a comparator, and it's an integrated circuit that compares the voltage from this phototransistor here in the light and in the dark. Okay, so you can see we now have a green light showing. If I put my hand over this phototransistor here, you can see it goes red. Now, it's going to sit there and wait about 15 seconds in order for the train to complete its movement through the block going across the bridge there on the Rockfish River. And then it's going to go green again. There it is. So it's that straightforward and easy to use. What I am going to do here is, I got this from Rob Paisley. He made the circuit that I used for the grade crossing gates and signals in Charlottesville. And that was one of the chapters in my book, Wiring Projects for Your Model Railroad. And it works very, very reliably. Matter of fact, it is so sensitive that I actually had to cut down on the amount of light over it in order to get it to work. I was just providing too much light. And with this one here, on the layout, if I pass my hand over the phototransistor like this, it will shut off. But because I've got these photo lights here for shooting the videos, I have to cup my hand over it in order to cut out a certain amount of light. It's that sensitive to the amount of light. So be aware of that. This works in very, very low light, room light settings very well. If you have a very, very bright setting, you might have to cut back on the sensitivity a bit. Okay, now what I want to do is I want to take you to the computer and go to Rob Paisley's website, and we'll take a look at that circuit. And then I want to show you the version that I went ahead and transferred from his electronic circuit to a plan, basically, for the wiring of this circuit board here. Because, you know, what you see in a circuit is not something that's easily transferred directly to electronic components on the board. So what I'm going to be doing hopefully before this video goes live, is I'm going to take photographs of the top of this board and the components here on the bottom of the board, because you can see I've hand wired this whole thing, because I'm not making more than about 2 of these. And so it's very easy to knock out 2 of these by hand. It takes a couple of hours to wire these once you get the circuit wiring figured out. And that's what I will show you. I will provide you with a photograph, close-up photograph of this side of the board, and a photograph of the top side of the board. Okay, and then I will also provide you my hand-drawn circuit, layout of the circuit. That's basically this, and the wiring for the bottom, and let you go from there. And you know, it can be a little bit complicated. Once you've got one working though, and tested out, then all you have to do is copy what you've done. And hopefully that will get you started on signaling on your model railroad. Now, I will point out with respect to this circuit here, on Rob Paisley's website, he has a number of circuits that he provides circuit boards for. So you might want to check with him if you're interested in building this circuit. He might have circuit boards already for this. And he also has other types of these, other designs based on this one circuit. Right here, I've got a pair of capacitors included. And the reason for that is it gives a delay. So that gives me that 15 to 20 second delay. So you get about 1 second per microfarad. So these are two 10 microfarads wired in parallel, and that gives you about 20 microfarads. And so I get somewhere between 15 and 20 seconds of a delay after the train has cleared the photodetector and before the light is triggered and goes back to green again. On the original design, he had a 3.3 microfarad capacitor. I just went with 20, and I used two of these because I didn't have a 20 around or anything close to it. So I just went with this pair of these guys. He also has circuits designs that allow you to use two of these wired in series. He has another circuit that can use multiple detectors within a train section. I tried wiring two of these in series and ran into a problem because every time I turned the DCC power on the layout, the light would trigger. And I could not figure out what was going on, why that was happening. My best guess is that the long unshielded wires that I was using to run between the two photodetectors were being influenced by the DCC power bus. And so I just dropped it back down to a single and went with the 20-second delay. And that works fine. In the future, I might go back and give it another shot with shielded wires. And I don't have any of that right now on hand, or I would have tried that. Okay, let's go ahead and take a look over here at Rob Paisley's website. Here we are on Rob Paisley's website. Up here at the top, you can see the web address, circuitus.ca/circuitindex.html. And down here, this is all these list of circuits. So there's just tons of stuff on here that you can just wade through. If you're interested in electronics and model railroad electronics, he just has a ton of stuff on here. And as I think I've said before, he does have quite a lot of circuits that he does provide boards for, kits for, and in some cases, he'll even pre-build the board for you. And in the case where I did the crossing signals on the Piedmont Southern at Charlottesville, he built the whole thing. I think it was about $8 extra to have him solder it all together and test it in advance. And so I went for it. That was a very, very inexpensive option. Okay, so let's go ahead and take a look at the circuits here. Now the one we want to go for are the light-activated train detectors. So let's click that. Let's see about photodetector circuits. Okay, so this is the one we want here, circuitus.ca/photodetectors.html. And you can see it talks about basic visible and infrared light detectors, how voltage comparators work, and they're the basis for this circuit. So let's go on down. This is the basic phototransistor comparator circuit that this is all based on, but that's not the one I use. So let's move down a little bit further. We want to find one. I'm going to move on down. Here we go. This is the one that I used right here, the relay driver circuit with a delayed release. If you do not want a delayed release, then you can just go with this one right here. So you can see it's a fairly simple looking circuit, easy to do. Okay, there's the one with the delay built in. So right here, this 3.3 microfarad capacitor shown here, that gives you about 3 seconds of delay after the photodetector is back in the light again. It will give you about a 3-second delay until the relay flips and your lights either come on or go off. And the way this works, this right here is your IC, the integrated circuit that has the comparator. And then basically you've just got a few resistors, this one capacitor here, and this diode placed right here across the leads to the relay, because if you don't do that, then when the relay trips, it can cause a surge back into the circuit and cause problems for you. And you don't want that to happen. As far as the relay goes, you want a very small PC board type relay that doesn't take up a lot of power. Basically, we're using this transistor here to be able to allow a slightly higher power use through this relay. But I'll give you some indications in the parts list as to the type of specifications you need to look for on this relay. And everything in here, this is set for 12 volts. I don't know, it might operate on 9 volts, I'm not sure. But I know the relay that I used is rated at 12 volts. So it's fairly easy to get yourself a 12 volt power supply if you don't already have one on your model railroad. So basically this is a fairly straightforward, but there are other circuits that he provides for setting up multiple. He's got 4 different photodetectors on this one, and then he has another one here where he has 4 of them arranged in series. And he says here that you need to make changes in the circuit in order to account for these 4 in series. Please contact Rob by email at this email address if you have any questions concerning any of the circuits on this website and whether or not he has parts for these various circuits and circuit boards, all of those kind of things. Because I know some of this stuff he does sell in a kit form, and some of it he sells pre-built. So this is my interpretation of Rob Paisley's circuit, and showing all the wires as I laid them out on the circuit board itself. And this is if you are looking down from the top and seeing through the board and what's going on underneath. And what I will do is I'm going to redraw this to give it a little bit more definition. I will also include a complete parts list, and I bought everything from allelectronics.com. So this will give you basically a plan for how you can go about building this circuit and wiring it up to a terminal here on this end and a set of terminals here. Because one of the things that I did include on the board here are these screw terminals here, again from All Electronics. And so this allows me to just screw in the 2 wires from the phototransistor and also from the power in and then the leads to the lights. Now I've been saying that I got everything from allelectronics.com. That does not include the phototransistors here. I believe I got these from Mauser. And I've got the original package, so I can look this up. So I'll give you that information as well. And these are a blue. I believe this is sensitive to both visible and infrared, because I bought these to be able to use them with infrared light if I decided to go that route. But they're very, very sensitive and work very, very well. Well, that's a wrap for today's video. I hope I've given you some leads on how you can go about building an electronic detection circuit, a photodetector circuit like the one I've built here. And as I said, I'll put various bits of information in the description for this video so that you can have a chance to take a look at Rob's website, and you can download my hand-drawn plan and photographs of the circuit that I built for this project. So that's it for today, and we'll see you here hopefully on Friday with another video from the DCC Guy. Bye now.